All right, another example. So it says let D be the region in the first quadrant bounded by these curves, and it says draw D and set up iterated integrals to find the area below that in two different ways. Okay, so the first thing we should probably do, like it says, is draw D. So why don't we get that drawing going here? Um, and oh, hit the wrong button. Okay, so we have, here's our little sketch, and okay, so in the first quadrant we have y squared, so okay, 1, and we have 1, okay, and I know there's a point there, okay, there's that, and then 2 minus x, so, and then this would keep going, but then turns out that the other one kind of intersects right here and comes down as a straight line and hits at 2, okay? And so kind of our region of interest is this triangular-ish region in here, okay? And then so if we think about this as an elementary region, okay, pause and think, okay, what type of elementary region is it? It is type 3. Okay, so we could do this in X or Y. I'm going to think of this as a type 1 region first. So if I think of it as a type 1 region, then okay, I need to think, okay, X is going to be bounded between two constants. Well, X ranges from 0 to, oh, there's two different pieces, right? I kind of have to break this up. So let's see. So X is going to be bounded. Okay, so here's my horizontal slices or vertical slices for X, 0 and 1, and then the other one is going to be 0 and 1, and the other piece is going to be from 0 less than X, 1 less than X less than or equal to 2, and then when I'm in that first piece, okay, this is going to make y bounded between 0 and x squared, and in the second piece, y is going to be bounded between 0 and 2 minus x. Okay, so then I can set these integrals up, 0 to 1, 0 to x squared, and then the function is x squared, and then dy dx, and then this one's going to be plus 0 to 1, 0 to 2 minus x, and then x squared dy dx. Okay, now, so that's a type, if I viewed it as a type 1 region, and I would get an answer, and it said two different ways, so we have to do this now as a type 2 region, and so that is where I'm thinking, okay, I'm doing slices this way. Okay, so in that case, I'm thinking that I'll do this in green. Actually, let's do it in purple. Okay, so I'm setting this up as y first. So y is a value that's going to be bounded between 0 and 1. Those are my constants. And x then needs to be bounded by two continuous functions. So on the upper, it is bounded by 2 minus y. And on the lower, it is bounded by square root of y. Okay, so again, you could write this, x is this positive square root of y, and rearranging this, x is equal to 2 minus y. Okay, and then with this, I actually don't have to split this one into pieces, because as you see in my red slices, I just have kind of one chunk. Okay, I have one set of continuous functions. So then I can say that this is going to give me the integral from 0 to 1, and then square root of, or then from the square root of y to 2 minus y of x squared, and then dx dy. Okay, so both methods are valid, and I believe we've completed the problem because we drew D, we set up the iterated integrals in two different ways. The first one we did was via a type 1 region, and then the second way was by a type 2 region.